8th grade math, test 24 study guide, problem number 1. We have to decide which expressions are equivalent to this given expression. And what I do when I have parentheses and then exponents on the outside, I go ahead and since this is powers of the same base, I copy the base and add these two exponents. Negative 3 plus 2 is negative 1. Now, the way I do power next to a power like that is I multiply. So here's when I add, here's when I multiply. Negative times negative is positive. The first expression, we simplify that one by, notice that they're all powers, right? Same powers. So I just, like I did up here, I add all the exponents. And using teams, I have 5 plus 3 is 8, take away 6 is 2. That's the same thing. Expression 2, when I'm dividing powers with the same base, I copy the base and I subtract the exponents. I go 10 take away 8 is 2. That's the same thing. Expression 3, again, multiplying powers with the same base, copy the base, add the exponents, but on the bottom, I'll do that part second. So again, that's where I copy the base and subtract. 0 take away negative 2 is, add the opposite, positive 2, that's the same. Or you could have just done this. If it's all multiplication, you could have just crossed out your 1's, right? And then over here, 1/2, well, 1/2 where the 2 is on the bottom, that'd be a negative exponent, so that doesn't work. 1, 2, and 3 are the answers. Problem number 2, we have a product of two scientific notation numbers, so what I do is I multiply my two coefficients. I take, let me bring this down here a little bit. I take 3 times 1 over 2, and I get 3.6, and 10 to the 10 times 10 to the negative second, just like I did in here. I copy the base and add those two, and I don't need to change my exponent at all because my decimal is already in the right spot. That's already in scientific notation. For 3, we have to solve this. So I go 1/4 times 8x. Well, 4 divided by x is 2x. 40 times 1/4, or 40 divided by 4 is 10. Then I copy the rest. Next, after I distribute, I combine like terms. I combine my two constants. 10 plus 3 is 13. Now I can solve. I work farthest away from the variable first. The opposite of positive 13 is to subtract 13, so I do it from both sides. That makes this go away. I have 2x equals negative 4. Opposite teams subtract. There's more negatives than positives. That's why it's negative 4, not positive. Divide both sides by 2, and the solution to this equation is negative 2. So problem number 4, we're going to pick all of these equations that have infinitely many solutions. So all I'm going to do is simplify both sides, and then I'm going to make a decision from there. I don't have to solve the whole thing. So simplifying means distribute, combine like terms. Before I distribute, I can do the rule for subtraction, right? Add the opposite. I draw 1, 2 sticks right there. If I have a negative outside parentheses, that's like distributing a negative 1. It's the same thing. So if I distribute a negative 1, negative 1 times 2x is negative 2x. Negative 1 times negative 4 is positive 4. Now I can stop. Both sides are simplified. I have the same coefficients, the same constants. That is infinitely many solutions. Next one, number 2. Again, you can do your rule for subtraction. I can do the rule for subtraction here, here, because that's like distributing negative 1. And I don't need to do it here, because there's a negative, but it's already an addition problem. So I'm going to distribute. I'm going to go 4 times 10x and 4 times 2. I'm not going to do 4 times negative 7. That's not next to it. It's not in the parentheses. Over here, only the negative 1 gets distributed because the 15 is not next to it. See the plus sign separating it. 4 times 10x is 40x. 4 times 2 is 8. Copy the rest. Negative 1 times negative 1 is positive 1. Negative 1 times positive x is negative x. Combine like terms. I have two constants. Again, use teams. I get 1. Over here, I have 15 x's and 1 negative x. So if I take away one of the x, I have 14 x's left. I see that I have different coefficients. If you have different coefficients, that's always one answer. I don't need to go on and find the answer because I already know it's not going to be infinitely many solutions. Equation 3, again, rule for subtraction. Rule for subtraction. Distribute. Well, I don't have to distribute on this side, right? So I can combine like terms. I add my constants together. These two, negative 5 and negative 7 is negative 12. Over here, 3 times x is 3x. 3 times negative 4 is negative 12. I only combine the x's with the x's. Over here, I only combine the constants. I don't combine constants with x's. And so this side is simplified. This side over here, 3x plus 3x is 6x. Simplified, I have the same coefficients. I have the same constants. That's infinitely many solutions. 4, rule for subtraction first. That's subtraction, so I do add the opposite. Draw 2 sticks. Add the opposite. Add the opposite. Here, add the opposite. Now I'm going to distribute and combine like terms. Negative 12 times 2x is negative 24x. Negative 12 times negative 2 is positive 24. Don't forget to copy the other stuff that you're not using. Equals Now I'm going to combine like terms. I'm going to add all my x's. I got 1 positive x here, 16 negatives, 10 negatives. If I do all those together in teams, I'm going to get negative 25 x's plus 17. After I combine my like terms, I see that I have different coefficients. So again, that has one solution. So my answers are 1 and 3. So for number 5, we have a graph, and we're going to use this graph to get our slope. So if I pick 2 points right here and I do rise over run, first of all, be careful. Make sure that all of your intervals down here, your numbers, are counting by ones. If they're not, you have to take that in consideration. So when I rise, I'm actually rising 1 because these all go up by 1 and go over by 1. If it was going up by 10s, I'd be rising 10, even though it looks like 1, right? So since these are all counting by 1s, I rise 1 and run 2. It's a positive slope, so my slope is 1/2. And I get that from the graph. So now I'm going to look at relation 1. So for relation 1, I can take the 2 coordinates that they gave me, and I go y minus y over x minus x, and I chose to do this point first to avoid negatives. You could have done it the other way. You should have still got positive 2/3 when you're done. Now 2/3 is the absolute value of 2/3 is more than the absolute value of 1/2, so it's steeper, right? If I had a problem and I go from one point up 1 and over 2, that's how steep it is. But if I go up 2 and over 3, 1, 2, 2, 3, it's a little bit steeper than that, okay? And if that doesn't make sense to you, then you just do 1/2 is 0.5, 2/3 is 2 divided by 3, that's 0.6 repeating, 0.6 is greater than 0.5. Relation 2. Relation 2, I can just look at it and see that I can do the same thing that I did in the last one. However, I see that I have the origin, or 0, 0, and a line that goes through 0, 0, 0 is proportional. So I just pick any point. I'll pick that point 5, 1. I put y over x, and I get a slope of 1/5. 1/5 is less than 1/2, so that is not steeper. Relation 3 is an equation, and it's in slope-intercept form. So the coefficient is negative 1/5, so the slope is negative 1/5. The absolute value of negative 1.5 is 1.5. That's more than half, so that's steeper. That's what I got that part here. Okay. All right, and then the last one, another equation, but I got to put this in slope-intercept form before I can look at the slope. So I'm going to isolate the y. I subtract x from both sides, and I have, don't forget that negative right there. I can't add these two because one's an x, one isn't. I divide both sides by negative 4 now. Now remember, x over 4 is 1/4 x. Negative over negative is positive. So here's the equation simplified. The slope is whatever's in front of x. My slope is 1/4. That's not greater than 1/2. So the lines that are steeper are relations 1 and 4. For number 6, we're going to solve this system. I'm going to pick one of the variables that has no coefficient. So I'm going to isolate that x right there. I'm going to take the x, add 5y to both sides, and now this is the same equation right here. Since my variable is isolated, now I can substitute that into the other equation. Make sure you don't plug it into itself. But you got to put it where the x goes in parentheses. Remember, in parentheses? So we have to distribute 3. 3 times 5y is 15y. 3 times 15 is 45. And I copy the rest. Distribute, combine like terms. So I go 15y plus 5y is 20y. So now I'm ready to solve this equation. I've simplified both sides. Now I'm going to get my variable isolated. I'll work farthest away from the variable first. I start with the positive 45. I subtract 45 from both sides. And I get, using teams, see they're opposite teams, so I subtract those two. There are more negatives than positives, so it's negative 40. Divide both sides by 20 by the coefficient. And negative divided by positive is negative. So the value for y for this solution is negative 2. Now if I plug that back into the other equation where I isolated the x, because now I need x, I plug it in with parentheses, I simplify, and I see that my solution is 5, negative 2. Problem number 7. Now, if it were infinitely many, the x's would have crossed out and you'd have the same constant. If it was no solution, the x's would have crossed out, or the y's would have crossed out, and there would be different constants. 7 says one equation in a system is this. Okay, and then we have 4 more equations. We've got to figure out which of those equations would make infinitely many solutions to the given equation, this given one right here. Now, I've taught you how to do this recently by putting them all in slope-intercept form. That's an important skill because that's how we graph lines that are not in slope-intercept form already. And it's also one way that we can answer this question instead of solving 4 different systems. That's too much work. But now I'm going to show you an actually quicker way of doing it. So again, if it's infinitely many, it's the same line, meaning same equation. So I'm going to manipulate these equations to see if I can get the same thing. Okay, so for A, you see how it says x, and then y and y. If this y right here is multiplied by divided by -2, this is 2 times bigger. This has to be 2 times bigger, and this has to be 2 times bigger. In other words, if I take my equation and I multiply everything by the exact same factor, the exact same number, it's the same equation. So this is not the same. Because negative y times -2 is negative 2. Excuse me. Yeah, negative y times -2 is positive 2. But negative 3 times -2 is not 10. And 1 times -2 is not -8. So that's not the same equation. These two will not make infinitely many solutions. B, if I look at this, this is 5 times smaller. This is not 5 times smaller. It's not the same equation. It's not infinitely many solutions. C, hold on now. You got to put them in the same order. So if I do the rule for subtraction and flip these around, this is the same equation. But I want it to look like this one over here. Now I see, so look at the y's right here, okay? This one is times -2 or 2 times bigger. This one is not times -2. So forget that one. That's not the same. D. So I take a look here. Excuse me. Here we go. D right here. So if I look at my coefficient for x, it's half the size. If I look at my coefficient for y, it's half the size, right? Half of 2 is 1. If I look at my constant, it's half the size. This whole thing, everything is exactly divided by 2. That means it's the same equation. That is infinitely many solutions with the given equation in the problem. Okay, so for number 8, stay fit charges some money. So we're going to let y equal the total cost and x equal the number of videos. Okay, so they charge $1 per video, 1 to x, plus $45 one-time initiation fee, membership fee. In other words, it's x plus 42. Fitness for you is just $4 per video, or 4x. When are they the same? I set them equal to each other. I solve the system, right? Substitution method. This goes where the y goes. I write them equal to each other. This is finding x. In other words, the number of videos when they're the same, I make them the same. And so I subtract x from both sides. I get this equation, divide everything by 3, and I get 14 videos. After 14 videos, these two will charge the same. So for number 9, we have a table. And if you see, first of all, if you know this is a line and you see that your x's are in order, it's very easy to get the equation. Okay, so I just see what's the constant rate of change. It's changing by, looks like it's going down by 5 every time. So the slope is -5. And look, I can see my y-intercept right there, right? It's 0, 0, so it's proportional. So my equation has to be y equals -5x. Number 10, same thing. I'm going to get my slope and my y-intercept. I can see the y-intercept. It's hitting right there at 12. See, these aren't counted by 1s. That's not 9. They're counted by 4s. So my y-intercept, or my b, is 9. And I go up 4 and over, but that's halfway. So let's go up 2 and over 1. I'm not actually going up 2, though, am I? I'm going up 4, 8. I'm going up 8. Wait a minute. Yep, I'm going up 8 and then over to 1 right there. Up 8 over 1. 8 over 1 is a slope of 8. The slope is 8. The y-intercept is 12. The equation is 8x plus 12. Now, in the answers, sometimes they try to trick you by changing the order. Slope still has to go in front of x, even if they put change this order here. Like you wouldn't put 12 in front of x because that's not the slope. That's the y-intercept. Number 11, we have a right triangle. And it says that one of the legs is 5 units and the hypotenuse is 13, so it has to be used. We're going to use the Pythagorean theorem. The 13 has to be the one by itself, right? The 5 can be A or B, it doesn't matter, but the long side has to be by itself. 5 squared is 25, 13 squared is 13 times 13, which is 169. Isolate the variable, subtract both sides, 25 from both sides. B squared is 144, but I need B, so I take the square root of both sides, and that makes B squared become B. Square root of 144 is 12. That's the answer. 12 says we have a right triangle. Now there's 2 options here. They say find the 2 possible lengths. So there's 2 options. One option is this. Both of those distances they gave you are legs. The other option is this. One's a leg, one's a hypotenuse. Remember, hypotenuse has to be the longer one. So we got to solve Pythagorean theorem 2 times for those 2 scenarios. Square root of 35 squared is just 35, and then we get 65 here. Add those two together, take the square root of both sides, and one option is that missing hypotenuse could be 10. The other option is this. What's the leg? Well, if I'm missing a leg now, I can have this again. Square roots and squares undo each other. Subtract, and I'm going to get the square root of 30. Square root of 30 is not a perfect square. It's an irrational number, so my two options are 10 and rad 30 for number 12. Next problem, 13. So for 13, they say the base is 15 feet long, so it's 15 from here to here, and the hypotenuse is 17, or the ramp is 17. We got to find the height. So this is Pythagorean theorem. I go a squared plus leg squared plus leg squared equals hypotenuse squared. We memorized 15 squared in class. That's just 225. 17 times 17 is 289. Subtract 225 from both sides. I have x squared. I need to know just x, right? So I take the square root of both sides, and I find out that the height is 8 feet. So for 14, we have a graph. Now, if I'm going to find the distance between these two, one way I can do this is I can just draw a right triangle. If they're going to give me the graph, I'll just do it that way. It's a little bit faster. So I see this side is 2 and this side is 4. So I use Pythagorean theorem. 2 squared plus 4 squared is 4 plus 16, or the square root of 20. That's an exact answer because that's what they asked us for. Number 14, this time, they didn't give us a graph. They gave us 2 points. Now, you can go graph that, but in that case, I would just use the distance formula. And yes, that would have worked for this problem as well. So I take these 2 points and I go x minus x. Where am I at here? There we go. X minus x. See my two x's? I subtract them. Squared plus y minus y, and that's two negatives because y is a negative. Squared, and then take the square root. So that's what we always do at the end of Pythagorean theorem problems, right? We take the square root. Okay. So 4 take away 5 is negative 1. Negative 1 squared is just 1, right? 1 times 1 is 1. And 2 minus negative 1 is, add the opposite, is 2 plus 1, which is 3. 3 squared is 9. So the answer is square root of 10. However, for this problem, they want us to give the answer rounded to the nearest tenth. So rad 10 is in between these two perfect squares. 3 times 3 is 9. 4 times 4 is 16. So I ask myself, is it kind of in the middle, closer to 3 or closer to 4? Well, it's real close to 4. So it should be about 3.1, maybe 3.2. The answer is 3.2. As long as you get close, you'll be right on that. Okay, so 16. We have a triangle, okay? And for the triangle, we have 2 legs, and we're going to find the hypotenuse. So again, a squared plus b squared equals c squared. The other thing that's different is we have decimals, right? 2 times 2 is 4. Now I want you to think about this. 12 times 12, most of you have that memorized as 144. Now, if there's 1 decimal space and you square it, there's going to be 2, so just put 2 decimal spaces in 144. Add these 2, just add the 1's together. And take the square root of both sides, like we always do for Pythagorean theorem, and that's not a perfect square, so there's my answer. That's an exact answer. 17, we have these points over here. They are transformed to these points over here, and it says what transformation occurred. Okay, well, I'm looking at this, and I see that this looks like it went down 3, this one went down 3, and this one went down 3. So I know it went to the left 3. My y's went up 1, up 1, up 1. Up 1 means rise 1, so 1 up, 3 to the left is the translation that happened. So we're going to do these 2 transformations for 18. So we start out at negative 3, 0. And if I'm going to reflect over the y-axis, I change the sign for y. So negative 3 becomes 3. Now, how do I do this right here? This means go to the right 3 and down 1. Or just do exactly what they say. Add 3 to your x. That's going to give you 6. That's how you go to the right 3. And then take away 1 from your y. 0 take away 1 is negative 1. That's how you go down 1. There's the answer. 19, we're going to do these 2 transformations. Okay, we're going to go 90 degrees rotation clockwise, then 3 units to the right. Well, 90 degrees rotation clockwise means this. We switch them and change the sign for the second. We got to memorize those rules if you haven't already, right? All right, and then we go 3 units to the right. So I just add 3 to my x's and I'm done. And 20, we're going to do these 2. So for 20, let's take a look at the options. If I'm going to slide and then dilate, okay? So I know I'm sliding because adding and subtracting is slides, right? They're translations. Multiplying, putting a coefficient, is a dilation. And since the scale factor is greater than 1, it's getting bigger. So let's take a look at our options. Number 1 says the image in transformation 1, the slide, has an area that is 4 times greater than 2. Well, from 1, all they did is slide, so it didn't get any bigger. And then from 2, if you have a scale factor of 4, it's getting 4 times bigger. So it absolutely didn't get bigger, it got smaller. So A can't be right. B says this: the image in transformation 2 moves the original triangle 4 units in each direction. Well, the image in transformation 2 moves the original in each direction. That means it's going out 4 like this. That's not really true. It actually has a center of dilation. It's going in one direction as opposed to in all directions. Unless the center was right on the origin, that's not true. Okay, but it says here it's getting slid, right? And then it's getting dilated 4 times bigger. So B doesn't work because it's not moving the original. It's moving the second one, the first translation. Okay, I don't know if I confused you there. So B doesn't work. Okay, because there was a slide before it. So C, all but one of the vertices in the image transform 1 is different from the original. So all but one of the vertices in the image of transformation 1 is different from the original. So if transformation 1, we slid to the right 4 and up 4. So all those coordinates are going to change, okay? And it says all but one. That's not true. So they're all going to change. They're all going to slide, not just part of the vertices are going to slide. That's why C doesn't work. And D, transformation 2 has a perimeter that's 4 times greater than transformation 1. Transformation 1 was a slide, perimeter doesn't change. Transformation 2 was a dilation with a scale factor of 4, and I know that from the coefficients. That gets 4 times bigger. Perimeter is the exact same factor, that many times bigger, or proportional to the scale factor. Okay, that's not true for area. Area is the scale factor squared, but for perimeter it's the same. So that's number 20. Hope that helped.